I think I'll begin with the next question here. The next question it says cos square theta over 1 plus tan square theta plus sine square over 1 minus cot is equal to this. Well, a very similar question is there in the textbook. The working will remain be same. Let's start with the working of the first part. We'll be starting with LHS. So what I'll do here, I'll be converting tan as sine by cos and cot as cos by sine. So if I do the LHS here, say cos square theta as it is, this is 1 divided by, this is 1 minus tan is what? Sine theta by cos theta. Is a plus sign, numerator sine square theta, that divided by 1 minus cot theta, and cot is what? Cos by sine. So it's cos theta by sine theta. Next, I'll be taking LCM. So if I take LCM below, right? So it's cos square theta, that whole divided by, if I take this cos theta as LCM, so this comes out to be what? Cos theta multiplied by 1 is cos theta minus sine theta. This is what? This is sine square theta, that divided by, if I take LCM below, it's sine theta. And this is what? Sine minus cos, right? Sine theta minus cos theta. Now, next, what you know that dividing is same as multiplying by the reciprocal, right? Dividing is same as multiplying with the reciprocal. That's what I'm going to apply here. So what I'll do here, this divided by this is same as this divided by the, sorry, once again, this divided by this is same as this multiplied by the reciprocal of this. So this is cos square theta. On multiplying with the reciprocal of this, cos will be multiplied with this cos square. So should I write cos cube theta? It should be clear, I suppose. And below it is cos theta minus sine theta. We have a plus sign. Same I'm doing the other side. So it should become what? Sine cube theta. And this is what? Sine theta minus cos theta. Now, this important thing that I want to say here that, right, this is cos minus sine and other is sine minus cos, right? The other is sine minus cos. This is sine minus cos. I'm going to make some changes over here. I also want this to be sine cos minus sine, right? And that is possible if we change this my plus sign, right? On changing this sign, or I can say just the logic part is I'm just taking minus common here so that it becomes cos minus sine, and we'll make this as negative, right? So let's say if I do this, I can do it here. So this is cos cube theta, that divided by cos theta minus sine theta. And as I said, I'm going to take minus common over here. So sine will become minus, right? So this plus becomes minus now. And the sine cube theta as it is. Now it's easy to understand since I've taken minus common, the cos will become now positive and the sine will become negative. Well, needless to say, I did so that I get the same LCM over here. So now we get this as cos cube theta minus sine cube theta, that whole divided by cos theta minus sine theta. Now in the numerator, you can see that there is an identity, right? And what is that? A cube minus b cube. And what is it? It is a minus b bracket a square plus b square and plus ab, right? That's what the identity it is. So let's say split this. This is a cube minus b cube is what? A minus b. So it's a minus b multiplied by a square, which is sine square theta, plus b square, which is cos square theta. and minus AB, minus sine theta into cos theta. And this whole divided by what? Cos theta minus sine theta. Now check here. This cos theta minus sine theta get cancelled. And what do you know as? What do you know as sine square plus cos square? Sine square plus cos square is what? 1. So I can write 1 for this. Right. I'll be writing 1 for this sine square. 1 and minus whatever is left, which is sine theta dot cos theta. And I think this is what the RHS, yes. This is the RHS here. Got this. So LHS is equal to RHS, and hence this is proved.